So we've been asked to construct a parabola that sits into this rectangle. This rectangle is 145 millimeters high, 115 millimeters wide. So just make those lines a little bit clearer. Just bear in mind these are not part of the parabola, but so as we're all clear on how we construct it, I'm going to just draw these in. Okay, and just for clarity, I'm going to label these corners so I have something to refer to. Now, first thing I need when I'm constructing a parabola is I need my axis, and the axis will also give me my vertex. I know that my axis travels through the center of this rectangle. It perfectly bisects it. To find that line, set my compass to over half of the line that I want to bisect. Strike that arc, and without changing the setting in this, set that on point B, the opposite end of the line. Now where those 2 points of intersection occur, I know that is the very center of my line AB. So I can draw that in dotted lines, or I can draw it in one continuous line. Doesn't really matter. The main thing is that that is now my axis. That is my axis, and the top of the axis we know is point V. So already I have 1, 2, 3 points on my parabola. Now to find the rest of the points, I want to divide this line A to D and this line from A to the center of AB, so to this point here. I want to divide them both into an even number of segments, so the same number of segments to each other. It doesn't matter what that number is, it could be any number at all, as long as it is the same on the bottom and the top. So the book took an example of dividing into 4 even sections. I'm going to divide this into 5. So I'm taking any angle at all off the line. I put in that line. Now I want to divide this into 5 even parts, perfectly even parts. So I'll set my compass to what looks to me like approximately a fifth of that line. I haven't measured any of this. So with each point I strike, I place the point of my compass onto that point of intersection, strike the next point. One, two, three, four, 5. There's 5 sections there. Right, 1, 2, 3, 4, 5. What I'm going to do is label them. If I take this point at A as 0, I'm going to label these points as they go away from point 0. 1, 2, 3, 4, 5. That's critical that we number away from the point of origin down here. Now, if I connect point 5 back to where I want it to go, at the corner, and make sure those points are meeting, and to make sure that I have plenty of room to slide here, I'll place my set square that's under my left hand down quite low. If I started up here, I know I'm going to run out of room as I go down along here and have less of a point of contact. So best practice, set the set square down here. Now this set square on my left hand does not do any more movement. I clamp it in place. Connect these points back. Set square in my left hand doesn't move at all. It's clamped into position. I'm holding it down tightly. And the 45-degree set square is able to slide freely along that I should say. Now, all of these to these points, they're all perfectly equal. It divides this line equally. So I want to do the same for the low line. Again, any angle at all will do. And I want to divide that also into 5 even portions. So same point of origin, and I'll go 1, 2, 3. Can that be seen in the camera? Zoom out a little. 4, 5. So I have 1, 2, 3, 4, 5 points along this line. And again, I'm going to use that to perfectly divide this line here. Using the same technique, connect my last point to the end of the line that I want to divide. And I've got 1, 2, 3, 4. I can connect up the last one just to show how I got the angle. So I have a series of points along here. I'm going to label all those as well. That's 1, 2, 3, 4, 5. To be clear, that's that point is the point that I'm labeling. Now, here's the trick when we're drawing in parabolas. The points that are running across the base, you remember this is a conic section, it's a section of the cone. This line down here is a line on the base, the circular base of the cone. From it up, we draw our lines parallel to the axis. Our lines on the left, however, of the side here, are not parallel to the axis. These lines all connect back to our vertex. Vertex, remember, is the highest point on the axis. So if you hold the point of your pencil on V on the vertex, line it up with the next point, and then bring your pencil back, you'll keep good precision. Now remember, these are also 1, 2, 3, 4 and 5. Now where 5 meets 5, here and here, that's a point on our parabola. We already knew that. Where the line 4 meets this line 4, that's another point. 3 where it meets 3, 2 where it meets 2, and 1 where it meets 1. We already have our point of origin down here in the corner, so that is going to be the shape of our parabola. Now we can complete that parabola because we know a parabola is symmetrical. whatever happens on this side of the axis line also happens on this side of the axis line. So we can take the axis as our line of symmetry. Everything is copied symmetrically from that line. In other words, if I transfer that line, these lines across, all of these points across, I can then use where they meet the axis as a center point to mirror all of these points over. So I've transferred them over. Take my compass again. Set the distance out to there and copy that point over to the other side. Set it to there, transfer the point over. Set it to there and transfer the point over. And that's my final point of reference. So I now have all of the points of reference that I need. I can set aside my T-square and I can connect up these points. I use freehand sketching again, and remember I want a smooth, even curve the whole way up. It's not a radial curve, it doesn't have a single radius, just the same as the ellipse, lads. It runs between these points of contact in a nice smooth curve. There's no sharp point on a parabola other than where it begins and where it ends, and both of those points are at the bottom. They run along the base. So I'm using freehand sketching to very lightly sketch in the shape of the parabola. This is just the same as the technique we were using to draw our ellipses in, lads. And you remember from the last question how important these hand sketching skills are for graphics, lads. You have to practice them, they're going to be used. So I can fill that in a little bit heavier. Don't worry if you have to go over it a few times, lads, it's going to be worth it to see the curve drawn well. Make sure we're passing through all of these points of reference. That rule does not change from drawing ellipses, lads. Every point of reference must be precisely passed through on both sides. So again, once you've done one side, once you've done one half of the parabola, everything on a parabola is symmetrical through the axis. I know it's a continuous curve, guys, because if I connect up any 2 points that are either side of another point, there's no straight line through that. The point in the center will always be above that line. So that's drawn in nicely. I'll take pen and ink just to make that clear. No sharp points, lads. It's all nice and smooth, continuous curve. that's it, back to the base again. No harm ever, lads, to just fill in a couple of key labels on a drawing. This point is point V, that's our vertex, highest point on our axis. This is the axis itself. Those are the key parts of that drawing. Got an axis of symmetry, got V is the vertex at the top. So we're using the division of lines method to divide this side evenly and the base evenly. Up the side, up the height of the parabola, these points all go back to V, whereas along the bottom they are projected up parallel to the axis, so they go straight up and down. And that's how we draw our parabola.